Very good morning to my dear students. I, Harita Malani, working as an assistant professor in Electronics and Communication Department of Manikyalal Verma Textile Engineering College, Bhilwara. Today, I am discussing my lecture in continuation with previous lecture on IC 555 timer. That day, I have discussed the basics of IC 555 timer, its pin configuration, its internal structure. Now, in continuation with my previous lecture based on IC 555 timer, this topic is related with electronics design lab, which is helpful to perform experiment based on IC 555 timer. So in continuation with that, I am discussing my next topic is a stable multi-vibrator. So what is a stable multi-vibrator? It is a free running multi-vibrator. That means its stable state is not defined. The timer can switch on and off depending on its external trigger condition. So this is known as a free running multi-vibrator. It is classified as symmetric and asymmetric stable multi-vibrator. Symmetric means this timer is based on duty cycle. So duty cycle is a ratio of on time upon the total time of the output wave. So if duty cycle is 50%, that means at the output we are getting T on and T off time similar. That is, if total T output is 1 millisecond, so T on and T off are divided by 50%. So 0.5 and 0.5. So that is, we can say that a stable multivibrator can be used to generate rectangular wave or square wave. If it is generating square wave, that means its duty cycle is 50%. Then a stable mode is known as symmetric stable multivibrator. So this is the diagram in which external two resistors and one capacitor is connected. These are resistors connected externally and one capacitor. So internally three resistors are there where VCC is connected. This is lower comparator, this is upper comparator, threshold comparator, this you can see it as a trigger comparator. So depending on the voltage levels at trigger and threshold comparator, this comparator will generate 0 or 1. When this capacitor starts charging, when I have switch on this device, this capacitor will start charging through the resistors R1 and R2. And what will happen? Capacitor voltage at this terminal will try to increase, which is connected at negative terminal of lower comparator. Positive terminal of lower comparator is connected directly to 1 by 3 VCC. So when this is charging, 1 by 3 VCC voltage is more than the capacitor charging voltage. So what will happen? Positive terminal voltage is higher as compared to negative terminal voltage as capacitor is charging. So first threshold condition, trigger condition is 1 by 3 VCC. So what will happen? The output, Q bar output will be 0. Why it is 0? Because S is 1. This is plus terminal is high, having higher voltage as compared to negative terminal. The output of lower comparator will be 1. Upper comparator threshold voltage here is 2 by 3 VCC and voltage at the non-inverting terminal is less than 1 by 3 VCC. So output at upper comparator will be 0. So the flip-flop will turn as 1 and 0. Q and Q bar. So now what will happen? This is 0. So capacitor output will be 1. This is a power amplifier inverter circuit. Output will be 1. Once the voltage across the capacitor reaches 1 by 3 VCC. This reaches 1 by 3 VCC. What will happen? The trigger comparator will output 0. But at this point, that won't do any change as both R and S inputs of the flip-flops are 0. So the voltage across the capacitor will keep rising. So at this threshold condition, 1 by 3 VCC, the capacitor voltage will increase, keep on rising. Once it reaches 2 by 3 of the supplied voltage, the threshold comparator will output 1. So now the upper comparator will output 1 to the R input. Now the condition changes. This is 1, this is 0. This is shown in next diagram. At this moment, output of the 555 timer will go low. So this is shown in the next diagram that upper comparator is giving you output as 1, lower comparator output is 0. So Q bar 1, output is 0. Now what will happen? This transistor will get on. Now this transistor will get on. But once the voltage across the capacitor drops to 1 by 3 of the supplied voltage, the trigger comparator will output 1. This will turn off the discharge transistor. So now transistor is on. When Q bar is 0, transistor is off. This should be clear. When Q bar is 0, transistor is off. When Q bar is 1, transistor is on. So initially what is happening, that capacitor is charging. Capacitor is charging and it charges in between 1 by 3 VCC and 2 by 3 VCC. That is my capacitor voltage. So it is shown in this figure. See, this will turn off the discharge transistor when Q bar is 0. So this process of charging and discharging between 2 by 3 VCC and 1 by 3 VCC of the supplied voltage will keep running on its own, thus producing a square wave on the 555 timer output. So now this is my output voltage, and capacitor voltage will charge and discharge between 1 by 3 VCC and 2 by 3 VCC. We can calculate the time output is high and low using the shown formulas. The high time depends on the resistance of both R1 and R2 as well as the capacitance of the capacitor. So this is my charging path, this orange line, R1, R2. Now discharging path. When capacitor will get discharged? As soon as this Q bar pin is 1. When this Q bar pin is 1, when the upper comparator outputs 1. That means this voltage is increasing till 2 by 3 VCC. So now capacitor will start discharging through the path C1, R2 through this transistor and ground. So the discharging part depends on resistor R2 and C1, and the charging part depends on R1, R2 and C1. So this should be clear. This is the concept. This stable multivibrator you have to perform in your lab experiment. You have to find out its duty cycle. You have to find out output waveforms. Output waveforms are very clearly shown in the diagram. So now we will discuss this equations. These are very important equation. Output high and output low duration, that is, and by adding these I will get the total output. It is determined by the resistor R1 and R2 and capacitor C1. This can be calculated using below formulas. So high time T1 second, this is high time T1 seconds given by 0.693 R1 plus R2 into C1. Why all these three external components are used? Because these are used for charging of capacitor. When capacitor charges, I get a high output voltage. Time low. Low time depends means it is discharging path of capacitor, and discharging depends on R2 and C1. So this is 0.693 R2 C1. Now total time period T high plus T low, I will get the equation. Next, to find the frequency, we all know frequency is 1 upon time period. So it is 1 upon the formula which we got for time t. Now the total frequency is given by this formula, where we are having in 1.44 upon R1 plus twice R2 into C1. Twice R2 because R2 is involved in charging and discharging of capacitor. Now very important parameter, duty cycle. It is a ratio of time for which the output is high to the total time. Very important parameter because multivibrators generates output in the form of on and off. So we have to calculate duty cycle. Duty cycle ratio is given by R1 plus R2 upon R1 plus twice R2 into 100. And this figure elaborates very clearly how I will get my outputs. So in a lab experiment, you have to find this output T high and T low. Duty cycle will be given to you 60%, 70% for a stable multivibrator. Then you have to make the circuit connections. You have to find the values of R1 and R2. And then you have to make the connections, find out the output, find out the duty cycles, and afterwards you have to match theoretical and practical values of both. Now I am showing one figure in which there is a breadboard, power supply is connected, 555 timer IC, two external resistors, output resistor, capacitor is connected. So this is overall regarding a stable multivibrator and how you have to perform in lab. Thank you students. Please go through this video and try to learn new things about 555 timer as a stable multivibrator.